So is there any in there you want to work?
I want to know what was the tolerance thing, like plus minus.
Well, we agreed in this class, we were gonna carry it to one decimal, we're gonna round it to one decimal point, right? And you'll probably see, the answer sheet is rounded to one decimal point.
I like to say this though, just by doing, law and Watt's law, this right here had me thinking I need to do an extra step. You know, just looking at it, like we get so much to do in it on the electrical side, we still gotta solve the turn and everything else. When we saw it, it's kinda like done.
Well,
It made me feel differently.
well, yes, but yes and no, but still, you got two, you know two things you can always solve for the third, and that's in Watt's law, that's in Ohm's law. It's just that they kept jumping around.
Right.
So, and that's just in there to make you think. So if you can do that, then you understand it. I didn't like it because the worksheet didn't have y'all solve for area. In the test, you're gonna have to solve for area. So this gave you the area in square inches, so it made it a lot easier, and I don't know why the worksheet's laid out like that. I might go back and redo it. Like I said, this is not one of my classes that I normally teach. I taught it, fall, I taught it, the fall term, and that was the first time I taught it in like 5 years. So are we okay? Everybody okay? See if y'all want to work. Y'all did okay on that. And, we'll move on. And I got another worksheet that I want y'all to look at too before we go to lab, and make sure y'all understand that, because when I looked over the test was basically the same thing, but you had to solve for the area. The area was not given to you. What's the formula to solve for area? Diameter squared times 0.785, right? And that's the little thing, if you keep floating that in your head, you're
That's what we did on the,
yes. But the first worksheet didn't have you solve for that. This worksheet gave y'all the area. So, I mean, it was a lot easier. I could understand, I might go back there and redo it where, instead of having 8 of them, they give you the area, start with 4 of them, but they give you the area, and after that, you have to solve for the area. So what we're looking at, and this is chapter, I don't know what chapter it is, on direction or valves. So this is pretty straightforward. Y'all have been dealing with valves all your life. So what do we do with valves? What do we you said we could control things. You can't control me with a valve, right? And I'm a thing. So what do we mean? What do we control with valves? Control the flow of fluids. Yeah. And this is, so we control the flow of fluids with valves. Oh, let me pause this.
Okay. All right.
The next thing we talk about is the number of positions we can put the valve in. That would be, and basically you can put it in 2 positions or you can put it in 3. So we'd say if we got 4 ports, it would be a 4-way, 2-position valve. It depends on the number of ports. You gotta have at least 2 ports. Everybody understand that? At least 2. You gotta have an input port and an output port. So you got your water, you got your faucet at the house. You got 2 ports on it. You got one where the water runs out in your sink, and then you got the one with the pressure and the valve in the middle. Well, we call that a 2-port valve. We call that a 2-way valve. So the ports are called ways. Everybody understand that? And in the valves, you got 2 positions we can either put these valves, and these we're not controlling the flow. So your house, so it's kind of like a water fountain. You either do what with a water fountain? Off and on. Or your washing machine, when it dumps that water in there, it's either what? Off or on. So we know that's a 2-port valve, right? You understand, or two-way valve. And we know it's got two positions. One of them be the what position? One of them be the on position. One of them be the off position, right? Does that make sense now? So the number of ports that we port the fluid through, we call those waves. And then the number of positions you can put that valve in, we call that position. Everybody okay? Makes sense now? I mean, what don't make sense? You have to let me know. I mean,
I'm just saying, I'm trying to imagine how this is controlled. We're talking about 5 ways.
well, that's what we're going to talk about. All you need to know right now is the number of waves, is the number of ports, and then we have the number of positions we can put that valve in. Right? You understand? So what you're trying to do, you're getting over here. What I'm trying to teach you over here, right? Understand? Because we do have 5-way valves, but we're going to look at them, and once we show them to you, it's okay. That makes sense now. Because if you can control the direction, so your valves you have at home, you don't control the direction. Okay, you understand? So a 2-way valve, you don't control the direction. But if we're going to if we're going to be able to swap the direction of the flow, then we're going to have positions that do that, right? Does that make sense? The type of element that we do, pipette, spool, disc, we have different things. Primarily the valves we're going to use is going to have a device called a spool. That's actually in there taking care of the direction for it. And in the methods of operation, mechanical, electrical, manual, or pilot operated. Everybody okay? So if you got a gas water heater, we got a flame that we control the flame with a water. You got a gas water heater. So you got a main flame, a main burner. What lights that main burner? What is that power? Another flame. So you're controlling the flame with a flame, and that's what pilot is. So we'll control the position of the valve with the fluid that it's controlling. So these are some valves we should be pretty knowledgeable about. Gate valves, globe valves. Globe valves, all the valves in your house are globe valves. If you ever had to change the washers in them, never had to do that. So it's a globe. That's what a globe valve is. Then we have a needle valve. Needle valves, I couldn't find any animations on those. But needle valves, these are the valves that we use not only to turn things off or turn things on, we can precisely control the flow with a needle valve. So we're going to have some valves we call flow control valves. And what that's going to do is that's actually going to control flow of the fluid. So our valves that change the direction, all it's going to do is it's either going to change the direction or stop the flow or start the flow, right? And then if we want to control the rate of the flow, we're going to use a needle valve, but we don't call it a needle valve, we call it a flow control valve. That makes sense so far? So these are some animations of these different valves. So that's a globe valve right there. That's basically the way your sink works right there. And a gate valve, which is on the right. You can see why it got that name, gate valve. One they didn't mention, the one on the left, but we have one of those here. It's a butterfly valve. You might have ran into these ball valves. These are usually got a handle on the side, and the advantage of those is it's real hard to control the flow, which you don't use it. Normally we use these ball valves to turn it on or off. So I got one of these on my water heater. I put real fast the first time I had to change that water heater out. So you had to go out there and turn your main water off your house. So when I had it off, I put these ball valves on there. So now if I ever change my water heater off, I can cut that off right there and take my water heater out. Still change that. And then what we call a plug valve. Now the only ones I could find around here was this right here. This is the butterfly valve. This valve, you probably sit around, this is low valve. Yeah. And this right here is the gate valve. This plug valve, but the plug valve is very, very similar to the ball valve. But instead of having a ball, it's just a bar that goes in there. It's got a hole bored into it. You turn one side up, it blocks it. You turn the other way, and the hole lets the water flow over. And like I said, I couldn't find one on my needle valve. These are all what we call animated gifts. I used to have the application to make these, but I can't find them now. I don't know what I do with it. Are we okay? Everybody okay? Any questions? We okay? Uh-huh. That's the butterfly. Yeah, something turned. Something turned. No, something turned that rod coming out the side. It's just not in there. Yeah. Might be. Oh yeah, this is actually a check valve. Huh? Hello. So this is a check valve. We'll look at it in a minute, but it uses the butterfly, but it uses actually what's called check valve. Let's put it down a little bit. Oh wow. So these are just some things: gate valve, globe valve. This is the pictures that would stand out of your textbook. That's worksheet. When the college owned the bookstore, they closed at 7. So I don't even know that. We operate several ways, of course, manual operated, self-actuated, do call these pallets, mechanical, electrical, solenoid, pneumatic pressure, pilot operated, hydraulic pressure, pilot operated. Then we have what we call solenoid pilot. Probably not. I was working on this right before I came over here, and I didn't. Yeah, the solenoid pilot operated valve is probably not even covered in the textbook, but we run into that a lot in pneumatics. You know, we have some hydraulic valves that are over there, and what's wrong with it? Well, solenoid. I don't think I brought any wires over there. Maybe something like that.